One of the most unusual features of our planet is the large dry region extending from East Africa to Western Asia along the Indian Ocean. True desert environments extend all the way south to parts of Kenya and Somalia. There's only one other true desert which reaches so close to the equator, the Sechura Desert on the Pacific coast of Peru. Even farther south, there are savannas in East Africa at the same latitude as the Congo rainforest. What's also unusual is that this dry region is on the western side of a major ocean, the eastern side of a great landmass. And none of this information is trivial if you're interested in human evolution, ecology, or world history. For instance, many anthropologists believe that the dry savannas of East Africa were key to the evolution of early hominids. Some anthropologists believe that other regions in Africa were just as important, but even so, East Africa provides something key. It provides a connection between the savannas and dry woodlands north and south of the rainforest, even during wet interglacial periods. This gateway may have been important for creatures that needed drier habitat, including, potentially, our own ancestors. The ecosystems of these dry regions are fascinating in their own right, of course. They're home to unique animals like the Grevy's zebra and the reticulated giraffe, for instance, who differ from their close relatives in coat pattern and in their greater tolerance for hot, dry conditions. So, why is this region so much drier than we might expect? Why do deserts reach so close to the equator here, and why are there such vast savannas at a latitude where rainforest is more typical? There are several factors at play, but to understand these factors, we first need to understand the intertropical convergence zone. If you've taken a high school earth science class, you've probably seen this diagram of climate on an idealized Earth. Intense heating at the equator forces air to rise, and as it rises, it cools. The water vapor then condenses as a result, producing intense rainfall. This area of intense rainfall is known as the Intertropical Convergence Zone, or ITCZ. The air that rises here then sinks over the adjacent subtropics. This air then rushes back toward the equator as wind, but the wind direction is altered by the Coriolis force. The Coriolis force causes winds to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. As a result, the winds rushing toward the equator curve into easterly winds that we call the trade winds. Our actual planet, however, deviates wildly from this simple diagram. Because this is a heat-driven process, it's heavily influenced by seasons, especially over large continents, where seasons are more drastic. The Intertropical Convergence Zone moves toward the hotter hemisphere as it experiences its summer season, because as far as the atmosphere is concerned, the hot region has moved. Because it's so large, the interior of Asia heats up rapidly and intensely in summer. As a result, it makes the Intertropical Convergence Zone swing wildly to the north in summer, farther north than any other place on Earth. This is the Asian monsoon. As winds rush toward the Intertropical Convergence Zone in Asia, the Coriolis force causes them to curve into westerly winds. As a result, water vapor from the Indian Ocean mostly goes to the Indian subcontinent and Southeast Asia, not Africa, the Arabian Peninsula, or Iran. Africa, of course, has a monsoon of its own. The Intertropical Convergence Zone swings well to the north of the equator, and monsoon winds come from a southwesterly direction. These winds carry moisture recycled from the rainforest and from the Atlantic, watering places like Sudan. But these monsoon winds run up against a formidable barrier. Mountain ranges extend from Eritrea all the way south to the Congo rainforest. As the monsoon winds are forced up these mountain slopes, they produce torrential rain. You'll find lush tropical forests in southwest Ethiopia and other East African highlands, teeming with chameleons and blue monkeys. In fact, this is where our coffee tree originated. Coffea arabica is an understory rainforest tree originating in the tropical forests of southwest Ethiopia. But these same mountain ranges, which support lush forests on their western side, also create a severe rain shadow. They create much drier conditions on the eastern side by capturing the moisture of the monsoon. So during summer in the northern hemisphere, the monsoon mostly skips over this region. In winter, it's a different story, but with a similar ending. Asia becomes relatively cool compared to the Indian Ocean, and the higher pressure causes winds to rush off the continent, where they curve into easterly trade winds. These easterly winds pick up moisture from the ocean, and they will bring autumn or winter rain to Vietnam and southeast India. Unfortunately, they don't do the same for places like Yemen or Somalia, thanks to the orientation of the coastline. These winds mostly move alongshore rather than onshore as they head south. The portion of Africa that's in the southern hemisphere has its own monsoon season during this time of year because it's summer there. Recycled moisture from the Congo rainforest heads south, and these winds curve into northwesterly winds due to the Coriolis force. But the Great Rift Mountains capture most of this moisture before it can reach places like Tanzania. The same water vapor which rose out of the Congo rainforest falls as snow in parts of these mountains, supporting alpine glaciers despite the equatorial latitude. The mountains serve as a divide between the savannas of the east and the rainforests of the west. While it may seem unfortunate that East Africa's coastal winds don't bring rain during summer or winter, they've also played a huge role in human history. Because these winds are so reliable and so strong, merchants have used them for thousands of years. They've connected the people of East Africa, India, and the Arabian Peninsula. And during the transition seasons, when these winds aren't drawn far to the north or to the south, rain-bearing trade winds do head toward this region. There are two other factors which create dry conditions in Kenya, Somalia, and the Arabian Peninsula. One of them is the ocean itself. As winds rush toward the Asian continent during its monsoon season, they move a great deal of water in one direction. Although the winds are moving south to north, with added Coriolis force, the net movement of water is offshore. This produces coastal upwelling, or deep, cold water coming up to the surface. This is the only large-scale coastal upwelling system on an eastern coastline, and it has a profound influence on the region. Because as hot air rises over the much warmer eastern side of the Indian Ocean, near Indonesia, it sinks over this much cooler side, where air is not rising so intensely. The sinking air, or higher pressure, prevents the convection necessary for rainfall. On the bright side, this coastal upwelling also brings nutrients to the surface, creating an incredibly rich fishery off of Somalia's coastline. Finally, dry conditions are also encouraged by something called a low-level jet, an area of fast-moving air near the surface. I've discussed this in a previous video on the Southern Caribbean. In this case, air accelerates toward Asia during its monsoon season, and where air at the surface is accelerating, it's leaving faster than it can be replaced by more incoming surface air. As a result, air from above sinks down to replace it. Again, sinking air prevents the convection necessary for rainfall. This jet, called the Somali jet, creates very dry conditions around the jet entrance where the air is accelerating, and it creates enhanced rainfall at the jet exit where it is decelerating. Another low-level jet, the Turkana jet, forms during the same time of year thanks to the extreme pressure difference between the cool ocean and the hot interior of Africa. Extreme heat in Africa creates a strong low pressure, which draws in cooler and denser air off of the Indian Ocean through the only gap in the mountains of East Africa, the Turkana Basin. On the plus side, these strong winds in the Turkana Basin generate an enormous amount of electricity for Kenya. Unfortunately, they also create very dry conditions in Kenya and Somalia because this is where the wind accelerates. Where the wind decelerates in Sudan, it creates booming thunderstorms and lush pasture. Although Mozambique and its adjacent regions are not nearly as dry as the Turkana Desert much farther north, they are made drier by the presence of Madagascar. Most of Madagascar is a high plateau, which captures moisture from the trade winds for a large part of the year and casts a rain shadow to the west. Hence, you can find lush rainforests on the east coast of Madagascar, but woodland and savanna is the norm in the areas downwind. In combination, all of these factors have drastically increased the amount of savanna and desert in Africa and Western Asia. I hope this video has illustrated just how complex and diverse the climates of our world can be. As always, the sources for this video are in the description. Thanks for watching. If you find these topics interesting, consider subscribing. There will be many more to come.